This conference will now be recorded.
Good morning, everyone. Screen and audio both are fine or not? Please confirm.
Yes, sir.
Yes, sir, both are working.
Why is so as you know, yes. Good morning, everyone. Screen and audio both are fine or not? Please confirm. Is it audible?
Yes, sir.
Yes, sir.
Okay, thank you. So as you know that you are here for the physical design demo session, right? Before before starting, right? So I would like to ask some questions to you. So you all are from the I mean electronics branch only, right? Mostly majority are from electronics or EC or electrical, or is there anyone who is from computer science branch? No, right? Mechanical, civil, no. I guess. Okay, Sharon, you are from computer science branch. Okay. And all are recent pass out or
Yes, sir.
recent pass out? Mostly, I think. Okay. So, so can you tell me like you are which year pass out? Is it recent 2026 or 2025? 2026. And
2026.
anyone from 25, 24, 22, 23? Okay. 21, 20, 19, 17, 18. Anyone who is from previous year pass out, you can mention. Okay. 7. Okay. 24, 2020, 26, 2016. Okay. 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 So how many of you are from PhD or MTech background? Anyone from PhD or MTech background? You can mention. MTech, okay. CSC, okay. C electronics. Hmm. Okay. So, okay. Fine. I got the rough idea. Okay. So let us start discussing physical design. Before starting physical design, you must be knowing that physical design is part of VLSI flow, right? So when we talk about VLSI, right, what do you understand by VLSI? That is more important. So when we say VLSI physical design is a part of VLSI, VLSI is a like a ocean, and in that physical design is one of the domain which is there in that VLSI flow. So if I ask you what is VLSI or what do you understand by VLSI, can anyone tell me?
Millions of transistors onto a single.
Sir,
Millions of transistors onto a single chip.
onto a single chip.
Process of integrating millions of transistors
Hmm.
onto a single.
Process of integrating millions or billions of transistor on single chip, right? Anything else you want to add up? Anyone? Any other answer? That's correct. That we are integrating millions or billions of transistor on a single chip. So when we talk about a chip, what do you mean by chip? What is chip? It is made up of, chip is made up of, what is that material which is used to
Silicon,
semiconductor,
semiconductor.
right? So semiconductor material is used to create a chip. That is why it is called a silicon chip, because silicon is one of the material, semiconductor material. Which one is the other one? So when we say chip, right? What is the other one? So you say that okay, it
Germanium,
is a silicon chip. Where yes, other semiconductor name is nothing but germanium, right? So if I ask which one is more better with respect to design, VLSI design, silicon or germanium? Why silicon? So better with respect to design, I am asking. Which one is better? So
and
silicon
energy band
has
also.
conducting threshold voltage. What is that? zero point 0.7, 6 to 7. Yes, mostly we will take zero point 0.7 only, close to zero point 0.7. But what about germanium?
1.1,
0.2 to 0.3.
0.
So usually we'll round up to 0.3 only while calculating. Okay, so by threshold voltage, you can observe that zero point 0.3 is better or zero point 0.7 is better. How zero point 0.7 is better? Which one will conduct faster? Zero point 0.7 or zero point 0.3?
Content.
Right? So if you draw, this is zero point 0.3 and this is zero point 0.7, right? So which one will conduct faster? Germanium or silicon? Obviously germanium. Germanium is better compared to silicon with respect to designing, right? Because it conducts faster. So obviously it will help us in performance. But then why you will not listen about germanium? You will always listen about silicon chip, semiconductor silicon chip. But nowhere you will hearing about the germanium. Why is it so? Because now comes second point, which what is your name? Which Sumant has told that silicon is abundant in nature, right? Whereas germanium is rare compared to silicon. You cannot find easily. So the extraction process is very costly. So that is why we won't go with germanium for mass use, right? Mass means commercial use. So if you want to use it's not like germanium is not used. Germanium is also used, but for very specific application like space program or military upgrades or medical appliances. Right? So very rarely used. So 98% of chips are made up of silicon only. Why? Because it is abundant in nature. So why we are telling that it is abundant in nature? What is the reason?
We're getting it from sand.
Because it is extracted from sand, right? So and we know that sand is everywhere, so it can easily extracted in cheaper cost, in less cost, right? So how it is done? So we will take a bulk of sand, and then it will be melted through, it will go through process, and from that silicon will be extracted in form of ingot, right? A cylindrical shape of silicon will be extracted. Okay, so this is called as ingot, silicon ingot. Now observe that it is a cylindrical, right? It will be like this. It's not like so it is cylindrical in shape, this ingot. Now what happens next? So you have observed that how potato wafers are made, right? Chips. You have eaten that Lay's chips or something, right? How it is made? You will purchase potatoes and then slicing it into what? Wafers. That is called as wafers. Some people will call potato wafers also, right? You take a potato and then slice it. After slicing it, what you will observe, the cross section of the potato chip will be something like this or not, right? Similarly, the ingot, silicon ingot, which is extracted from sand, it will be sliced, right? Sliced multiple number of times to get what we will get? Wafers. So these are called as silicon wafers, right? Then what will happen? Then on top of it, right? This is one silicon wafer. Then on top of silicon wafer, then transistors will be fabricated, right? Transistors, circuits, designs will be fabricated on this chip. So what is that process called as? That is called as fabrication process. The process of fabricating or integrating all the transistor into a design, into a circuit is called as fabrication process, right? So what happens that on this wafer multiple number of identical chips will be fabricated, right? Now why I am drawing like this? So assume that this one square is nothing but a one chip design. It is a one chip design. Let's say some design, we will say that there is ARM Cortex 7, ARM Cortex M0 is there. So this is one chip, let's say. Okay, so ARM Cortex M0, this is one single ARM Cortex M0, right? Like that, multiple number of times ARM Cortex M0 will be fabricated in each square, right? Understanding? It's like farming, right? Have you might have studied, or you might have seen also farming. How farming is done in India? Farming is small scale farming. So there is a difference between large scale and small scale. The small scale means you will have a big region of land, and it will be partitioned into multiple small plots. In each plot they will grow rice, right? Here also rice, but it will be having separation. You might have observed or you might have studied, right? So why it is so? Why it is like this, right? Because it improves the productivity and the quality of the grains, right? So what happens? We are growing rice here also, here also, here also, here also, everywhere. Understood? But is the rice quality and quantity is same in each and every plot? Will it be same? So suppose I am extracting 100 kg of rice from this plot, and here whether I will get same amount 100 kg in each and every plot? Why? Why? One is no, all area is same, not bigger or smaller. Let's say area of each plot is same. Let's say area is A only. All area is A for an assumption. Okay. So whether we will get same amount of rice. Why?
Some negligible difference between them.
Hmm. Weather condition and what else? Soil quality and water, how much amount of water is given, right? So what you are telling that there is a variable. So there are a lot of factors which is variable in nature, which is not fixed. So in some plot maybe you will leave more amount of water, in some plot maybe less amount of water, in some plot you will add more fertilizers or less fertilizers. So this is called variation. Similarly, on chip also we will have variation, right? That is called as on chip variation, right? So the variation, the variable factor is there in agriculture also, and here also we have variation factor that is called as on chip variation. Now why this is there, why it is present? So in agriculture it is because of water, soil and all, right? But why there is a variation on chip? Hmm? While fabrication process, that's correct, absolutely correct. So we need to understand what is fabrication process. So fabrication process goes through lithography, photolithography. Now what is photolithography? What is etching process, right? Do you ever heard about etching process? You might have done in your college also, right? So you
Yes.
might have taken one copper clad, you have printed the design on PCB to get the PCB design, then you have mounted the components or not. So what is that process? That process is called as lithography process, photolithography process and etching process. So what happens? Can anyone explain this? How you have done PCB design? Have you done PCB design in your college? Right? Not done? Then right? So you will be taking one copper clad, right? On top of copper clad, through some software like Eagle, or manually drawing, right? Using permanent marker or something, right? Or you are printing the design on top of copper clad somewhere. Either you do manual or you print the design on this copper clad. So let's say you have printed this design on copper clad, or why we are doing this? You'll use some black marker or some print, black print. Why you are printing this design? Hmm? Of course, for connection only. But why you are drawing it? We want only those copper part to be present, right? Apart from that, everything should be washed off. So why we are doing this? Because this is acting like a photoresist. Suppose this is my circuit. So why I am drawing this? It is acting like a photoresist, right? Which is resisting what? Photons. Photon is a parameter of light, right? Light particles. So it will resist what? Photons. Why we are resisting photons? We want copper material to be present in this region only, this network only. So once it is done, what is the next step you will perform on this PCB copper clad? So you will dip that in some solution, right? Some sort of solution. What is that solution called as? Some ferrichloride solution you will use, right? So in ferrichloride solution, when it comes in contact with UV light, plus you have copper clad in that. So you have a copper clad, okay, dipped in this solution. What happens next? Under the presence of sunlight, right? Why we are telling sunlight? Because sun rays have UV particles, right? UV radiation. Sun rays have UV radiation. Under the presence of UV radiation, ferrichloride solution, copper reacts and copper gets washed off into this ferrichloride solution if it is constantly moved. You can do this experiment at your home also. Very cheap experiment. You just need to purchase one copper clad, use permanent marker, draw the design by your hand or scale, something like that, and you can buy this powder also. It's very cheap. Okay. So once this is done, what is this process called as? Etching.
Itching.
So what we are doing here? Etching of copper. So copper part is etched off. So what we will get in the end in the design, in the copper clad, right? So from everywhere copper will be washed off. Only this part will be remaining, right? From everywhere copper part will be washed off. So after etching process, you will get this connection. Then later on you will do drilling and you will add components. You will mount components by soldering or something, right? So this is called as photolithography process. It is called as photolithography process. Same method is used in nanotechnology fabrication also, but with higher standards, but with higher process steps. It's not simple in nanotechnology. Why? Because here we are talking about very high scale. You can see those network or not. You can see that copper network or not. Whether you can see semiconductor silicon network on chip, whether you can see all those network on this chip. No, right? Why? Because we are designing at the nanometer scale. Now when we talk about nanometer scale, right, that is why it is called as nanotechnology also. So whether it is visible through your naked eye, no, right? So can you tell me currently in industry on what scale designing is done? Nanometer, 0.4 nanometer. Zero. Which company is doing that? So see, it is not in market. So that is in experimental phase. Okay, I'm talking about which is present in market. So you can find easily 3 nanometer designs available by Samsung or other companies like Qualcomm, Broadcom. They have already, those chips are there in market. So of course, some other Intel, they are working on 1.8 nanometer, less than 1.8 also. In Armstrong also they are working, but it is not still in market, right? Even 2 nanometer is also going to be there in market soon. Okay. So when we talk about this scale, what do you understand by this number, right? When we say it is 28 nanometer technology, it is 14 nanometer technology. What do you understand by this? What is these number? What are these numbers? Anyone? Hmm? What is that? Size of the chip. Is it correct to say when we say technology node, right? Is it size of the chip or size of the transistor?
Size of transistor.
So, but size of means, see, when we say transistor, transistor is a 2D or 3D. Is transistor a 2D or 3D? Definitely a 3D, right? So which part of dimension you are telling that it is 90 nanometer or 180 nanometer, right? So this is right, Vaidehi. It is nothing but the channel length of a transistor. So this is your diffusion layer, right? Silicon dioxide, polysilicon, right? This is nothing but diffusion layer, poly, right? It is nothing but a transistor, transistor 3D. So which part of this transistor we are telling that it is nothing but channel length, right? So channel length, we are telling that, okay, 28 nanometer, 14 nanometer, 10 nanometer, 180 nanometer, 19. These all are what? Channel length of a transistor. So this is the physical form of transistor, not the representative form. So this is what which is going to be getting fabricated on those silicon. So how it will fabricate? So silicon is what material? Which type of material? So what are the types of silicon material? Yes, what are the
P-type
types?
and N-type.
Yeah, what is that?
P-type and N-type.
Right. So basically there are two types only, N-type material and P-type material. How you are going to get those material? So it is a
By
pure
adding
silicon,
impurity.
right? It is a pure silicon. From pure silicon, how you are going to get this?
By
So
adding
by adding,
impurity of
yes, correct. By adding impurities.
bivalent and pentavalent material.
So what sort of impurities you are going to add? So there are two types, N-type or P-type. If you want to get N-type, you are going to add pentavalent atoms or trivalent atoms. Pentavalent atoms, right? And if you are going to, if you want to, yes, if you want to get P-type material, you need to add trivalent atoms. What are pentavalent atoms? Can you name some? Pentavalent means what? Which has 5 atoms in valence band, right? What are those? Boron is pentavalent. Huh? Nitrogen, forgot. These all are part of basics. That is why in course we will also include basics part also. Initial starting 3 months or 2.5 to 3 months, you will have basic refresher sessions where you are going to learn digital concept, where you are going to learn CMOS concept, so that you can get refreshed. Maybe this part you have studied somewhere in third semester or long back. Now that needs to be refreshed. This is the reason we are going to add basics part also, so that you can refresh your knowledge. It's not that you do not know, you know it, but you need refreshing your knowledge. Okay. So okay, anyways, so pentavalent atoms will be added. So by default, any silicon wafer, yes, arsenic, antimony, or pentavalent. Hmm? It's okay, don't worry. So by default, the pure silicon, right, is P type material, right? So P substrate. So this is called as P substrate. Okay. In this, how fabrication is done? See, we need to get N diffusion layer also in this P substrate or that silicon material. How you will get? By applying photoresist on top of this, right, where you want diffusion layer, and then we will etch off that part. What part? P type substrate we will etching it off, right, and then we will diffuse it to make it N type material. How we are diffusing it? What we are diffusing it? We are diffusing with highly doped impurity. That is why it is called as highly doped. We are doping it with pentavalent atoms to get N type material. That is why it is called as diffusion layer. It is diffused with, it is doped with impurities. Like that you will get N type and another N type to get diffusion layer. On top of that you will have silicon dioxide and polysilicon, right? Like that, one single transistor is fabricated on silicon. Like that, millions and billions of transistors are fabricated on silicon, and then it will be connected through interconnects, and this material is nothing but metal. So what material is used for metal? Copper. Basically, majority copper is used to use for interconnects, for connection. Right? It is not a silicon material. Okay. But in lower techs, it is found that instead of copper nowadays, there is some sort of high resistance compared to the base material. We are using different metals also. It is not pure copper. So some kind of alloy is used nowadays. Okay. So, point of telling all this is to understand what are the parameters which can affect OCV, right? On-chip variation. Why we can see on-chip variation? Because process is very complex here. So during this process, multiple things can happen. What is that? Now, what is the process? So you will have one UV light source, right, and it will pass through some sort of lens, it will pass through some sort of mask, right, and on wafer it will get fabricated, the pattern will get fabricated, right. Suppose the pattern is something like this, so it will fabricate like this. Now what is this? This is called as mask, right? What is mask? It's like a stencil, right? See, during Deepavali you might have seen there are a lot of design stencils for making rangolis, right? You just use, it will be like nets. Have you seen that? Have you seen that in market? You just purchase that, add color on top of it. What will happen? It will imprint that design, right? What is that? It is nothing but a mask. It is nothing but a stencil, right? So for each layer we have stencils or mask. So for each layer, mask will be used to imprint that design on that material. Okay. When the UV light is going to be passed through some lens, right, and mask, and now during this process, what can possibly happen? See, light has a tendency, right? What is the nature of light? What is the nature of light? Yes, anyone? Mhm. What is the nature of light? Hmm? Reflect. Think.
Reflection, refraction, total internal reflection, transmission.
Okay. See, light has a dual nature, right? What is that? Light can behave as particle as well as wave, right? It can behave as particle as well as wave. That is why when we are saying it is a particle, it is showing the particle nature of light. Then we are going to measure it in terms of what? Wavelength, right? That is what we are telling, that all light, right, has different wavelength. What does this mean? Length means what? So we are telling a wavelength. It is not wave we are talking about. It is talking about the particle, how far that particle can emit. So if you have multiple lights, right, multiple color lights, white, blue, red, yellow, out of these, which one has the highest wavelength? Red, right? That is why in traffic signals you will see red as danger. Not in traffic, everywhere red is used as a danger color. Why? Because it has a highest wavelength. It can be visible from the far distance. Why? Because red light particles travels far compared to other light, right? So the wavelength of red color is highest out of all the colors. What about wave? Wave is measured through frequency, right? See, you have used torch, right? Maybe in childhood you have used torch and pointed towards the sky to check how far that light goes, right? What you find? Did it imparted on moon? Why it didn't reach till moon? Because of lesser wavelength, because of wave, because frequency is not that much enough to reach to the moon. But if you check laser light goes very far compared to the normal torchlight. Why? Because of wavelength, right? Because of its frequency. Same for infrared light. What happens infra? It is having more coverage. Like that we have UV light also. UV light has highest wavelength. That is why sun rays are coming till earth. Understood? So it has more frequency as well as more wavelength. But still, it may have some sort of limitation. This is also not perfect because we are working in a nano scale. Remember that? So we are working in 28 nanometer. Can you tell how small this size is? It is.
They're not visible to the naked eye.
So how small? Like whether it is small as your hair strand, or whether it is small as your nails, or whether it is small as a dust particle, how you can compare? So can you tell me what is the size of coronavirus? So coronavirus, right? It is a recent one only. Anyone? What is the size of coronavirus? You can check also in your phone if you want.
60 to 140 nanometer.
60 to So there are
140.
different variants, of course. So if at different variants, there will be different sizes. So 60 nanometer to you will find that it is reaching up to
140.
150 nanometer. So there are different variants for different variants, there are different sizes, right? Now on what scale design can be fabricated currently in market? 3 nanometer scale, right? So you can understand how small your design is compared to the coronavirus. How much small? 20 times. If we compare by 60 nanometer, it is almost 20 times smaller than the coronavirus, right? Even microscope will fail to observe these circuits. Understood? So that is the reason it's very complex. So once this light passes through the mask, there is a high chance of getting defects in design. It can do correction also, but there is a high chance of getting defects. So those defects can cause and produce underperforming chips. So that defects is coming through what? Process variation, right? That is coming through process variation. This is one, right? Like that we have voltage variation also. So what happens if voltage fluctuates? Marginally also. See why? Because it is at 3 it is a very low scale. 28 nanometer is also very small, smaller than coronavirus. Okay. So you can think at that scale how a small variation can also cause underperforming chips, right? So even small voltage fluctuation will also cause what? On chip variation, right? Like the temperature. So fabrication process also needs what? Some sort of temperature environment. If you see any fab lab, have you seen any fab lab? So in IIT Bombay, they have some experimental fab lab, right? They are not developing very low scale technology based chips, but higher technology only, but they have some setup. So it will be usually dark room, right? Very less amount of light is there, or some specific constant wavelength based light will be present in that room. And maybe you might have seen in photo or video, you might have seen that they'll be wearing some sort of jacket, right? White jacket, and completely covered and sanitized, right? There will be no dust particle, hand or hair, anything should not go inside that room. Why they are maintaining that level of standard? To avoid what? Variable factor. Even small variation which goes into this that room, it can create lot of difference, because design is made at very low technology node, or very critical scale, right? Even small variation can affect your design. That is why on-chip variation is very important in the design. Small variation comes, your chip may get defected or may become into underperforming chips. Same as agriculture land, right? All plots are not going to give you 100 kg. Some will give you 90 kg. Some will give you 80 kg. Some will give more also, 120 kg. So it depends. So how that variable factor affecting your chip? It doesn't matter, like if this part of chip is getting fabricated, maybe everything went well, so this chip will be overperforming also, right? Like that, if you see in the edges, so around the edges, most of the chips will turn out to be defects. Why? Because complete fabrication is not allowed in the peripheral of the wafer, right? If it is allowed also, we cannot fabricate complete chip. So that is why these all will lead to defects. Only some amount of chips will be functional. Only some amount of chips will be functional. Okay. So these chips, how much? So that is called as yield, right? Yield means what? What is yield? Anyone? What is yield? So in agricultural land also, you will calculate yield, right? What is the production? Out of total, how many good chips are there? Good chips out of total chips. That is nothing but yield, right? Understood everyone, this part? So VLSI is nothing but very large scale integration of transistors, billions of transistors. And there are multiple uh, things which comes into play and which affects your design. Understood this part? So it is what? Integration. Integration of billions of transistors on silicon chip, right? So the design, we are getting designed by integrating billions of transistors. That is called as VLSI. When we say now, see, it is also VLSI, very large scale integration, means in billions, right? So then we also have LSI, small scale integration, large scale integration, small scale integration, medium scale integration. We have ultra scale integration also, ultra scale integration, right? So it is all depending on what is the count of transistors which are getting integrated, right? This is only dependent on the count of transistor. So when we say VLSI, it is mostly lower technologies below 180 nanometer, all comes under what? VLSI, very large scale integration, because you can fabricate more and more number of transistor only because of what? Because transistor size is very small. If I give you this particular area A1, I'll give you another particular area A2. Okay, what is the difference? Let's say both the area is same, A1 and A2. Now if I take 180 nanometer, how many transistors I can fabricate in this? Let's say 100 transistors I can fabricate here. If I take 90 nanometer scale and I'll use it here, right? How many transistor I can fabricate with? Maybe I can fabricate with 200 transistor. Why? Because transistor size is reduced, right? So that is the difference between small scale to medium scale to large scale to the very large scale, right? It is helping us to increase more and more transistor count to fabricate in that same area, right? So in the end, how it is helping us, right? It is helping us in the application. Earlier, for an example, you have seen phones, right? Smartphones, or before smartphones, we have what? Keypad phones, Nokia type, right? Old days Nokia phones, very compact, only used for some specific application like messaging, SMS, calling, or some sort of small snake game. And it is kind of black and white screen also. There is no graphic card or something like that, right? So it is a very basic chip. Now evolution came into what? Semiconductor. Then what happened? Transistor size shrinked. So there is one law also, right? What is that law called as? Moore's law. What is Moore's law? For every 20 years. 20 years or 2 years? Hmm? For every 1.5 to 2 years, transistor size will shrink. By what times? Right? Okay, go through that. So nowadays Moore's law does not apply in Moore's law, because in lower techs, in FinFET technology, that does not apply. So that was when CMOS technology was there, or that MOSFET technology was predominantly used. That time it was very, we can follow that Moore's law, right? Basically, it says that for every 2 years, the transistor size will shrink, or the count of transistor will be double. So indirectly, it is saying that count of transistor size will be doubled. So what happened from starting from 250 nanometer, right? Shrink to 180 nanometer to 90 nanometer. What we have seen that more and more see, if you want to increase the memory in the design in the Nokia chip, right? What you have to do? So earlier you may be using, let's say for an example, for single unit memory, right? One flop you are using. It is a memory unit, one flop you require. But if you want more memory, definitely you will be requiring more flops or not, which should be connected so that you can increase the capacity of memory, right? But if you have limited amount of area with 250 or 280 nanometer, you cannot fabricate with more flops, with more memory elements, right? If you shrink it, definitely more number of flops can be fit into the same area. Like I said here, right? Area remains same. If you want to fit more number of things, so technology sizes needs to shrink. So that is the reason from Nokia to nowadays you are seeing smartphone with 200 megapixel camera, 100x zoom, right? And lot of feature. Touch feature has that frequency, that what we say, refresh rate of how much? 144 or 160 hertz. You are not checking all this on your phone. 140 hertz, 144 or something like that. You check. Okay, so it has a more refresh rate. What is the frequency in your phone or laptop chip? So you'll see high frequency chips nowadays, right? So very fast. So in Intel also earlier days we have Pentium 2, Pentium 3, 4, 5, right? Then dual core. So from this era we have what? Multi-core processors, multi-core chips, then quad core, octa core, right? Why we can have more number of cores, right? Octa core, hexa core. So why? Because transistor size is getting shrinked. That is why the, see, we don't want our, so if you want to make design more complex design, right? You don't want to carry your phone like a suitcase, right? You want it to be compact, but also it should include complex design to have more high-end applications, right? So this is how it is going to help in terms of application. Understood? So this is just an overview of what VLSI looks like from the market side. What you see, can you give some examples? What you see, where you means in what products you see VLSI chips?
Mobile phone,
Mobile phone and laptop and
tab,
tab, and so all those are mobile phone category. Apart from that, medical, where you have seen
EV,
ECG, where
EV,
TV, EV vehicles, yes, battery management system, very good. TV also, nowadays we are having smart TVs that also have silicon chip. That is the reason now you can use OTT platform, you can do touch, you can use it as computer also. How these multifunctionality came into TV, right? Now TV screen is also slimmer and slimmer compared to the earlier. Earlier TVs were made based upon what? CRT tube, right? That is why it was Dabba TV, big Dabba TV. Nowadays we are having what? Different technologies, OLED, LCD, right? So LEDs also, high-end LEDs also came into power LEDs, power LED TV also came, right? So these all are only because transistor size has been shrinked. Anything else? No, no, application. That's all. That's all you have seen. You're surrounded with, no matter what you see everywhere, you will find silicon chip only. You're surrounded nowadays in current present day, you're surrounded with VLSI chips. Military application. Can you give any military application, Harsha?
Solar cell.
What is it?
Radar.
Radar. Okay, right. Anything else? Walkie.
Drones.
Okay.
Drones also.
Drones, yes, very good example. Recently, you might have seen in news how drones are prominently used in every warfare between Russia or Ukraine, between India and Pakistan recently, or between US and Iran. How drones are predominantly used in these warfare, right? How those are controlled, how those are automated to hit the targets. That is only because of silicon chips. So how it is making greater impact, even if you check, see laptops, right? Power distribution control circuit. Yes, sir.
Aerospace.
Yes, in aircrafts also. Nowadays, if any aircraft is purchased from other nation, that nation has the technology IP, right? They, if they want, they can switch off the aircraft from there itself. You cannot use it even though you have purchased it. So that is called as something called as technology transfer. Unless and until they do good percentage of technology transfer, you don't have authority to use by it by your own. If they want, they can shut off your aircraft from remote location itself. So that kind of feature is also there. So if some nation purchases the F series, what Falcon series jet aircraft from America, US, they have that capability to shut it off. You cannot use it even though you have purchased it. So there are many applications, good, bad, everywhere, but it can have definitely greater impact in society. Even nowadays in washing, commercial based products, washing machine, AC, right? Inverters. Now everything is having cars. You might have seen ADAS system. What is ADAS system? It is kind of autopilot system for cars, similar to aircraft has a autopilot system. Nowadays, cars are also having autopilot system. You might have seen some videos from Tesla, right? Even from companies like Mahindra and Tata is also having nowadays ADAS feature in their cars, right? Yes, it is a autopilot system in cars. You don't need to change the gears or touch that steering to drive it, right? But for that, your roads and traffic rules should be robust, right? Otherwise, some goat or some buffalo will come on road, or some person will come, and that you know what will happen. You don't have to say. Okay, so this is what overall picture I wanted to tell you on VLSI. We will also discuss about physical design. We'll also discuss all more in technical terms. So just I wanted to brief you introduction on the VLSI part, how it looks in application terms, right? So I'll explain you the course structure here. So the course will be at least for 6 months, right? This is the minimum time if everything goes fine in right time, or there is a student's response also. If students are fast learner, if batch is fast learner, definitely it will complete on 6 months time. If let's say there is a batch who are slow learner or not very friendly in understanding these technology or high level concepts, so they will need some time. So for them maybe it reach to 7 months also, sometimes 8 months also. But if everything goes fine, the minimum amount of time required is 6 months. This is the fastest. Okay, so the basic PD basics will be covered in 2.5 months. PD advanced session means pure physical design concepts will be taught in next 4 months. Okay. So in PD basics, what topics we are going to cover? We are going to cover digital basics, CMOS basics, and some text editor also, like GBIM, right? You might have, some people have already used GBIM, right? It is nothing but kind of notepad. Okay, it is a text editor. Unix and Linux command. Why this is important? We know that industry works in Linux based environment. It does not works on Windows, right? Whatever tools are there, it is based on Linux based platform. Okay. Tickle scripting will also be taught to you. Tickle basics will be taught. Why? Because sometimes scripting, the coding, the programming can help you in your designing. Nowadays, we also have AI, right? So AI, you might be listening everywhere. Even VLSI companies are also adopting AI knowledge into the VLSI designs. So that is why this, from this course we are working on it, and sooner you will find in this course you will get to see AI integrated programs also with VLSI. So what we are trying to do here, how AI can help you in terms of the updating and automating the VLSI flow or the PD flow, right? If we can set up the PD flow through the AI, then our most of the task will be reduced, right? So that is what we are trying to integrate from this program itself, right? So CMOS basics will also be taught and some PD basics. So what will be the class timing for PD basics? So class will be daily from Monday to Saturday, 3 hours for each session, right? On weekends, Saturday, Sunday, 3 hours. Now, this weekends is only for what? For the weekend batches, right? Those who are working, those who cannot attend in weekends, sorry, weekdays, right? They can attend in weekend batches, right? Only on Saturday and Sunday. For others, for regular batch, it will be on Monday to Saturday. All and each and every session will be live recorded, okay? And those videos will be immediately uploaded on the same day itself. So even sometimes we'll give pre-recorded videos if some session might not get loaded due to some technical issues, then we will also give you older pre-recorded videos if that happens. Unless and means otherwise, live recorded sessions will be uploaded in your portal. Okay, any question here in PD basics? So you understand, right, what is the importance of learning PD basics? Because many of these topics you have learned long back and you need refreshment, right? For that reason, we are giving 2.5 months so that you feel comfortable in PD advanced sessions. Okay. Once you are good in PD basics, so some test will be taken. If you pass that test, then only you will be moved to PD advanced sessions, right? In PD advanced session, you will have so complete dedicated attention on lab as well as theoretical knowledge. So see, if you learn only theory, you can learn theory from anywhere. So nowadays lot of resources are there in Google, you can learn it, but unless and until you apply it, implement it, you won't understand anything from that theory. You also know that even though you memorize and by heart, you cannot keep that in mind for longer term. So you need hands-on on real industry-based tools. Now, what are those industry-based tools which are helpful to design nanotechnology designs, right? You have seen that it is how small. We cannot draw it from pen and paper or the pencil, right? It is at nano scale. For such complex design, we need some sort of tools. Those tools are called as EDA tools, electronic design automation tools, right? So those tools are from Synopsys and from Cadence as well. From Synopsys, it is ICC2, and from Cadence, it is called as Innovus. For STA, we use PrimeTime. For uh, for RC extraction, SPEF extraction, we use star RC. For layout, we use IC validator, ICV, right? And genus from Cadence is used for synthesis. For timing, we use Tempus, right? So what is the class structure? So class, on weekdays from Monday to Thursday, you will have lab. Timings can vary between 10 a.m. to 1 p.m. or 2 p.m. to 5 p.m. There are two slots. Based on different factors, students' response and trainers' availability, your slots might change. This is for regular batch, that your labs will happen on Monday to Thursday. For weekend batch, your labs will happen only on Saturday to Sunday, right? That is mostly on afternoon or maybe in morning. And for every batch, weekend plus regular batch, your theory sessions of PD Advanced will be common. That is on Saturdays and Sunday only. Okay? It will not be on weekdays. On weekdays, you will only have lab sessions, right? And why? Because theory session is on Saturday, Sunday for all, because the trainer from the industry itself will be available for you only on weekends, because rest of the time he has to work, he or she has to work in the company itself. So that is the reason the industry expert will be available only on Saturday and Sunday. Okay. Any question on timings? So once you have completed your course dedicatedly, if you have a good attendance, you haven't missed any part, right? So we will be providing you with the placement support and interview preparations support also. Manu Raju, how does the number of hours of weekdays matches with weekend? Whether all topics will be completed in the same time period for weekdays and weekends? Yes, it will be completed, Manu. So we are doing this from past many years. So in weekends, we will give you more time for lab, right? It's not like the tool access won't be there. So once we tell you something will be taught in for weekend batch, I am telling, not regular batch. Once you are taught in weekend batches that we have to do this, and this way you have to do, you have 24/7 access of tool. At any point of time, weekdays, night, or any time, you can work on it. You can practice on it. You have tool access 24/7 till course end. Means complete all these months you will have 24/7 access. Okay, for weekdays, they have for the regular batch, they can attend daily. For lab session, trainer will be available in offline. It's very preferable that you attend offline if you are in Bangalore. Okay, so that is how it will complete. So for lab sessions, there will be different regular trainer who has good hands on labs, who has practiced for many years. So that trainer will be provided to you. For theory session, there will be industry expert, because high-end concepts needs to be discussed. That is not easy part, and that is what some knowledge is required. That is why industry expert is provided for theory sessions. Someone told me that they cannot support MSc students because of eligibility criteria. So you have, Aniket, you have done MSc on which field?
Electronic science, sir.
Electronics and science. See, in my company, I have seen there are guys from MSc. Miss, still you can check with the management here, like how they can support or not. I'm not sure about this. But in my company, I have seen MSc from electronics. They are working in VLSI, in post silicon validation domain, right? I haven't seen in physical design, but I have seen them working in VLSI in different domain. That is for sure. That also I'm telling, in post silicon validation, I've seen one of a guy from MSc Electronics. I'm Pranita. I'm a BSc Electronics graduate and currently pursuing an MSc in electronics. I am genuinely interested in building physical design.
I have noticed that many institutes accept only BE Tech graduates, so I'm unable to enroll because. Could you please let me know if your institute accept candidates with BSc in electronics and who are pursuing in MSc? See, that's what same thing which I have told for Aniket that applies for you also. It's not like there are no people from MSc in electronics in VLSI. I have seen by my experience, I'm telling, I've seen in companies people from MSc electronics, they're working in VLSI. But working in physical design means I cannot assure that you can talk with management whether physical design for physical design is there any eligibility with respect to MSc electronics. But in VLSI, in post silicon validation also, in other domain also, I have seen MSc electronics people working. Okay, I think that will help you. Madhav sir, may I know about the advanced physical design course? Like who can take and will its batch start or later I can join in regular batch after phase 2 starts for regular batch? No, batches will be common. If batch is allotted from your batch itself, you will have PD basics and then PD advanced. Okay, so there will be no separate batches for basics and so if you want to skip the basics part, you are telling directly joining PD advanced. That can also be done, but it is preferred that you go through basics part. It will help you in your interview process also to understand what. So in basics part, we will also discuss what type of questions are expected in interview with respect to basics, because CMAS itself is a big subject, right? If you have observed, complete one semester is required, so that much of knowledge is not required. Only specific curated topics will be taught which is required to understand physical design and VLSI. You don't have to master in CMOS, you don't have to master in digital, but your basics should be clear. So that you crack some interviews, right? So that you get a good foundational refreshment, right? For that reason it is given. We also have some basic knowledge of application on our MSc Electronics. Yeah, I understand that. That's what I'm telling. MSc Electronics, Aniket, people are there in VLSI, they are working. I've seen. Pranesh, sir, can CSC graduates join PD advanced course? So PD, I cannot tell, and I haven't seen CSC graduates in physical design. But I have seen CSC graduates who are working in VLSI, but in software part, in programming part. See, this physical design or VLSI flow also needs some sort of flow support or flow software programming support. There you can see your scope. If you want to enter into VLSI, you can enter through programming. That is where I can see. Pranita, I asked to institute, but they said I can take up the course, but they will not be able to support with the placement. Yes, because the MSc you said, right? So like I said, it's not like you have a zero scope. I have seen people working in VLSI, some amount of percentage of scope you have, but of course that is not your upper hand. You have a lower hand compared to the BTech in electronics. That is what I can tell, right? Whether year gaps in issue getting into PD industry without, no, there is no issue with the gap. In fact, gap you have more opportunities to get into VLSI industry. Sir, when will the project gonna start? Okay, Yashashvi project will start from PD advanced session. Okay, from the day one itself. But in PD basics also you may have small assignments, tasks related to tickle scripting, Linux, right? Those things you have to perform. Those are not project, but it is kind of experimental assignments. So you have to do all those labs. Sir, how placement support works after training completion? Can you Yes, Madhav, I'm coming to that point. Do we need laptop in first month itself? Yes, you will be requiring laptop in PD basics also. Why? Because we are learning tickle scripting, we are learning Linux, we are learning GVim text editor. For that, laptop is must in PD basics itself. What is mine also? GVim is a text editor like a notepad where you can edit data, codes, programming, reports, anything you can edit. Okay. So placement support, once you complete your course, you will have placement support and interview preparation. Okay, so in this, the first step is test and assignments. After completing certain amount of concepts, right, you will be given with laptop. So anything above Windows 7, Sharon, anything about Windows 7 you can use laptop. Okay, so in placement support, what we are trying to do here, once you are completing the course or part of course, let's say you have completed digital electronics, so you will have one digital electronic test, final test, that you have to clear it. You have completed tickle scripting, so there will be tickle scripting test, you have to pass that test, you have to score good number. You will have next CMOS, like that. After each and every subject you will have test. Once PD Advanced starts, in PD Advanced, after each and every stage, you will have tests. Suppose floor plan completed. So test will be given, assignments will be given. You have to complete those assignments. So there will be one hard copy of material which will be given to you for your studies. Then there will be some 300 to 400 questions will be given as an assignment that you have to solve it, right? That will help you in your interview process. Okay. Similarly, the labs, in labs also you will be provided with some assignment. Whatever lab you are doing parallel to that, they will give you some additional experiment or task that also you need to perform. And this is about your test and assignment. Then comes mock interviews. So see, only having knowledge is not important. You need to continuously evaluate how good my communication is, how good I am expressing in my delivering my answers to the interviewer. Because sometimes what I have seen, students have knowledge, but they are not able to express or convey to the interviewer. Then also you will lead to failure. So for that reason, to remove your nervousness or remove your fear of asking or telling the answers, we will give you continuous mock interviews once course is completed, right? Or in the end of course, so that you get habituated to the interview process, right? So that you don't get that fear or panic or something like that, anxiety during interview process. So you will be feel comfortable, and continuous feedback and improvement suggestion will be given to you after each and every mock, like which topic you need to refresh, where you are weak, where you are strong, right, which part you need to improve. That feedback will be given to you so that you can work on yourself. That is about mock interview. Then comes interview preparation, right? The first part of interview preparation is the CV or resume, right? Which is like a biodata of yourself, career biodata. Okay. So in that, what will be present? Your name, your address. I mean, where your location is, right? Your career goals, your academics, your projects, right? All those you will be mentioning in your resume. That resumes will be continuously observed and filtered, right? You can validate from the soft skill trainer, right? They will validate if your resume is good or bad, right? So after that, you can also get through the FAQs. What are frequently asked interview questions that will be given to you, so that you can practice on that. So all these three process will be simultaneously, or sometimes after the session, after the course, it will happen. So this complete overall picture will make you strong in subject, confident in subject, so that in interview you do not fail. So this only works if you are sincere in class, not missing any class, attending. If you are present in Bangalore, attending from offline, then only this is a foolproof plan for you, right? So sometimes, so maybe some topics you are weak, you need some help, so that is also available here. That support is also, suppose you say that your batch says that we need to refresh our digital concept, we forgot, because that I have learned first month, right? So we will provide refreshing or revision session also for you for digital or CMOS. Sometimes I have seen that also in some batch. So that kind of support is also provided here. Okay. So these are the first steps: complete your course, complete your lab assignments, clear all internal test and mock interviews, interview preparation sessions, mock interviews you have to give, right? And finally, we'll be providing with the opportunities so that you clear that opportunity or the interview process very comfortably and confidently, right? We'll take some question and then we'll take a 10 minutes break, and then I'll explain the ASIC flow. For PD, do we need any set of knowledge on algorithm? See, algorithm wise in PD Advanced, so if I am teaching you, I will be definitely telling you. I don't know about other trainers how they teach, but for me, I have studied. I'm from the MTech background in VLSI design, also working in VLSI industry. So definitely from my end, I will be teaching you some algorithms also in placement, in CTS, or in routing. What kind of algorithm is used, right? To miss, that is, you will know where you will be working on algorithm in physical design. That is from my end, from my knowledge, I will be sharing those concepts also, because the tool is following those algorithms. So if you are going into tool development, definitely you need to learn algorithms also. Anup, my batch is the weekend batch. I want to watch the basic physical design videos, but they are not showing on my skills dashboard. Please guide me. Please guide me on what I should study in prerequisites before starting physical design course. If there is recommended learning order or any topics I should complete first. Kindly see, recommended topics, Anup, is first digital design subject. Okay. For that, you can follow Morris and Mano book. If you don't have any resource, you can follow Morris Mano book. Second is CMOS. So that for that you follow CMOS Design Perspective by Neil Westy. That will help you. So these two basics are must. Apart from that, you need GVim, Pickle, and Linux basics. As I said, from this program onwards, we are integrating AI-based flow also, which can generate AI-based VLSI flow. That also we are working on. Sooner, in maybe in 2 months, when your PD advanced session will start, that we will integrate with your common VLSI course, so that you can get to know how AI can be used in VLSI also. That will also play an advantage for you to get a good job. Shift that, sir, if the students want access to labs right from the PD basics phase, is it possible to get access? This I'm not sure, but yes, I think you can get access only for lab if you want, or only for tool access you want. Maybe there is a different way to get that tool access. You can ask with management, they will help you in that. Madhav, sir, may I know how many projects will be taught during the course? So basically, there will be one project which you will, two projects basically, but first project you will be working on it in line with the trainer, right? So trainer will also be performing and doing all the same jobs. So you have to follow the trainer. It is like parallel going with the trainer. It's not like completely independent of trainer. No one will guide you. It's not like that. The first project you will be doing with trainer itself, right? So that you can understand the flow tool, and you can also collaborate the knowledge of physical design concept, what you have learned in theory, that will also go in line. Second project will be given you as an assignment. There, no one will be there to help you, right? That you have to do it by your own. That is how you can have two projects. Okay. Pranita, I asked a few people, and many of them said that companies don't have many freshers for VLSI physical design these days. See, this is true that the freshers are usually not preferred in not physical design in complete VLSI itself, unless and until you are from the tier 1 college. Tier 1 college means if you are from IIT or NIT directly. So usually the VLSI companies, they directly take freshers from these tier 1 companies. Since there is no such thing called as mass hiring in VLSI, like in IT sector or computer sector, as it is a hardware designing, right? Where there is always less requirement. There is not like mass scale. If you see in colleges, L&T or some Infosys will come, and TCS will come, and they'll take 200, 300, 400 students in truck, and they'll take away or not, right? That is called as mass hiring. That happens in IT field or computer field. It's not the case in hardware designing, because here it is very concept wise also lot of vast knowledge is required. You cannot tell that I will learn only programming knowledge and I'll work. You cannot work here like that. You need good foundational basic knowledge, plus your critical thinking, plus your EDA tool hands on. So lot of things are there. That is why, so that is why less hiring is there, not too many mass hiring. Okay, so it's obviously that they will first approach towards tier 1 college. So that's why the most of the freshers from other college won't get that fresher opportunity. But this is only for the product company scenario. But there are a lot of service based companies also, like Mirafra, InSemi is there. Then we have Quest Global, BitSilica. Like that, there are many service based companies also. These people will be giving you opportunities in their company. Nowadays, even TCS, Infosys, HCL, these IT giants also, service based giants also, hiring for VLSI and physical design. So recently Wipro has hired around 100 or 150, 150 to 200 students they have hired in physical design for fresher role. Okay, so they are training also, 6 months more training they will get, but they are opting for the trained freshers, right? Mark this word, there is a difference between fresher and trained fresher. So freshers won't get that opportunity. For that, we have this training that will make you trained fresher, hands-on EDA tool. Which one will be preferred? By just by thinking, you will be knowing that okay, those person will be getting a chance who has hands-on EDA tool like Synopsys ICT, who has hands-on Innovus, who knows about what happens in physical design. Definitely that guy or girl will get the advantage over the college pass out fresher. Understood? That is the complete scenario. It's not like you will not get the opportunity. Definitely you will get, right? But not in product company. You will mostly get in service based company. Okay. Project assignments, can we add it in yes, of course. Yes, you can add in your resume. Whatever project you are working here, you can add it in your project, in your resume. Sharon, for freshers, what will be the max and minimum package depending on company? Okay, so the package is quite variable, right? I will tell you. See, if you go into product company, right, which is very less chance is there, right, unless and until you are from tier 1 college. So if you go as a fresher there, so your package can start from around 10 lakhs to around 15 lakhs, right? If you are going into service companies, right, definitely service company will have lesser package compared to the product company. So it will be starting around 4 to 5 lakhs, right, to 7 lakhs, right? Or yeah, so this range will be there for service companies. Yes. Yes, in service company you will also have bonds, right? So bond will be present between 3 years to, sorry, so different company. That is why I'm keeping this range. 2 to 4 years of bond can be. It is expected that bonds will be present between 2 to 4 years. Okay. Anything else related to this? Sir, I have a general question on behalf of everyone. From an industry point of view, what is the difference between physical design role and design verification role? Specifically, what kind of work would I be doing in each domain, and how to day-to-day responsibilities differ? So, Madhav, I will explain this after a 10 minutes of break. That is what I was telling. So in next part, right? So I've explained you course and overview, right? In next part, I'll be explaining you complete ASIC flow, right? The VLSI flow. The next part I'll become. So I've explained you chip fabrication and chip design process, what tools are used. So So next after break, I'll be explaining you ASIC design flow. There you will understand what is the difference between design verification and physical design. What kind of work is done in physical design? Okay. So what is there in design verification? Everything you will understand each, not physical design, you will understand each and every domain. Okay. So let's have a 10 to 15 minutes break, and then we will resume and we'll conclude in 1 hour. Okay.
Hello.
Yes, we'll resume from here. So let us know about the design cycle, right? The complete design cycle. So we have seen the overall picture of VLSI, how it is fabricated, what is the final product, right? We have seen course and how course is going to followed, what is the structure, what is timing, right? How selection process will happen. So everything we have seen. So we'll see the design cycle. What is the ASIC design flow when we say, or the design flow? So from where we need to start designing it? We have seen where it is fabricated. Now we have to check like from where it is starting, designing part. So basically design can be categorized into multiple things, right? So ASIC design is basically categorized into three different types also. But before that, we need to understand what is ASIC design. So ASIC designs are application specific integrated circuits. Now why we say application specific? Because when you are designing a chip which is meant for washing machine, that will only work for washing machine. It will not work with AC, air condition. Why? Because that chip is designed with respect to application. Whether your mobile processor, can it work in the laptop processor as a laptop processor? No, because application is specified there. Application is a mobile. So these kind of designs are called as application specific integrated circuits, right? So these ASIC designs can be categorized into semi custom design, full custom design, and programmable devices like FPGA. What is FPGA? Field programmable gate array. Why we are calling it as a programmable devices? Because it can be reprogrammed. Means suppose you want to change for different application, you want to use it for different application, you can use it. You can alter the design itself by dumping the binary code, right? So, for an example, in military operations or in military defense, they will use guided missiles, right? If you see Prithvi from India, there is one guided missile called as Prithvi. So, if you study about it, it has that feature called as we can we can change the trajectory of missile in air itself. So, once missile is launched, right? So earlier days, we cannot change the trajectory. It will hit the target. Suppose in the air itself, we have changed our mind to change the target from point A to point B. So that can be done only with the help of reprogrammable chips, right? Because in mid-air, you cannot go and change the chip and add different chip and it won't work. So somehow it should have that reprogramming capability. So that is only possible by reprogrammable chips. What are semi-custom based chips? Semi-custom based chips means so some part of design, the lower abstraction level blocks can be predefined and pre-designed, and that can be used multiple number of times to save time, right? Full custom design is a design where design starts from the lowest level abstraction level. That is what? Transistors. Transistor is the lowest level abstraction. So if you start designing from everything, you design it from transistor itself. Like I want to design inverter. I want to design a inverter pair. What is the functionality of this? What is the functionality of this design? Hmm. What is the functionality? Simple basics, right? What is the functionality? Inverse, inversely
Function
opposite.
like not get.
Is it inversely operation or same operation? Means
Two
inverse.
inverters, so same.
If I give 0 here, what I will get? 1.
No, zero.
You are only telling, right? Inversely.
Two for one.
So it will not inverse, right? It will give same. If you are giving data 1 here, you will get data 1 here, right? So what is the functionality? It is acting like a buffer, right? So this inverter paired design is acting like a buffer. So how this can be designed from transistor itself? So for that, a inverter can be designed using which technology, which logic? CMOS logic, right? CMOS is a combination of PMOS and NMOS network, right? Now what is this? It is a CMOS inverter design, right? Representative design. So this is PMOS, this is here NMOS. Okay. So this is here P out. Now this is what one inverter. So if I want to design it using CMOS or the transistor design level, right? I want to go to transistor design level. I need to add one more inverter, one more CMOS inverter, something like this, right? Now how it is working, right? So this is inverter 1, inverter 2. If both are connected in series, right, it will act like a buffer using CMOS inverter or using MOSFETs. MOSFET. So it is using CMOS logic. So it is what? Transistor level design. Right? So this kind of design method is called as full custom design. Same thing if I want to design it using semi-custom, what I will do? I will use cells, logic cells. Those are called as standard cells. Cell 1, inverter 1, cell 2, inverter 2. So this is what semi-custom design. I'm using pre-defined cell, pre-designed cells. I'm not designing it from transistor level. This is semi-custom based design, second one. This is full custom based design. But no matter what design we are designing here, right? This is for only small design. What if there is a processor design? Processor design will have billions of transistors. Can we design this using full custom? It will take a lot of time and we cannot assure that functionality is intact or not intact. So then what to do? Then we'll go with semi-custom based design. We will use pre-designed cells to get a processor design. But problem here is not the design, right? It's the complexity of design. What if it is a processor, a very complex design? What will happen? How much time it will take to design a processor? So suppose if I ask you, a mux has how many inputs and how many outputs? Yes,
Inputs single out.
for
Marks.
4 is to 1. So I should tell, right? Not to see, you should not assume. You should ask, is it a 4 is to 1 mux or 2 is to 1 mux? So let's say whatever you said, it is for 2 is to 1 mux. So how many inputs and how many outputs?
Two inputs.
2 inputs and yes, online 2 inputs and yes, Vaidhi, that is correct. So it's not 2 input and 1 output. It is 3 inputs and 1 output, right? Select line. Forgot that. So 2 data inputs, 1 select line, right? So select line is also input only, right? So I'm talking about inputs and 1 output, right? Now I want to design this 2 is to 1 mux. In how many possible ways I can design this? One way, I start designing it from transistor level, that is full custom. And another way, I can start designing it from logic level or predefined cell if I use it. Those are called as semi-custom designs, right? So let us say the first phase of designing is to decide what you have decided, how many inputs, how many outputs are required for 2 is to 1 mux. What is this? You're deciding specification, right? You're deciding specification. If you're going to market to purchase a phone, what you will decide? Specification, right? I want what megapixel camera, I want what memory, I want what RAM, I want what graphics, I want what display, what is the size of phone, right? All these are called as specification. Same way, I want to design 2 is to 1 mux, right? So what is the specification? What is the specification here? How many inputs it should need, right? How many inputs are required to design 2 is to 1 mux? 3 inputs, 1 output, right? So this is my specification, right, for 2 is to 1 mux. Okay, next, once you have decided, then you have to decide what? Architecture or design. Architecture means what are the components required in the mux. So what is required? I require gate logics, right? I will require, how many logics are required? Combinational logics are required. To design 2 is to 1 mux, what are the combinational logics required? Digital concept. See, it will be keep merging between digital and CMOS. Sometimes transistors, sometimes digital concept. That is why basics are important. Yes, tell me, how many combinational logics are required to design 2 cross 1 mux? What are those? Not inputs. I'm asking combinational logic. Combinational logic gates. Forgot when you have studied second semester digital? 2 and 1 not and 1 or. Right this. So you require 2 and, I will draw like this, 2 and 1 or, right, and 1 inverter, right or wrong? This is nothing but 2 cross 1 mux. This is my I0, I1, S0. This is output. right? So how many combinational logics are required? 2 and 1 or and 1 not, right? Now this is my like overall we can say the rough combinational design. Now I need to write RTL logic also. RTL logic. What can be the RTL logic? This is a logic design, not architecture. See, architecture is a big word. Okay, let's say you are using 200 2:1 mux, right? 200, 500 like that you are using, and you are using ALU also. Some different features like graphics, audio. That time architecture is because in your complete design in processor you will have graphics, memories, ALU, audio, video, modem, right? GPU, CPU. That time architecture is required. Here this is a small design. So here this is called as logic design. Okay, but before how you can define this logic design? How hardware can be defined using a code? So how many of you studied Verilog in your college? Verilog here. So what is that language called as? It is called as HDL language, right? So define the hardware. We require hardware description language. It is called as HDL language. So online, I hope many of you nowadays in college, in graduation itself, they're adding this HDL language in course, right? You might have studied. So basically there are Verilog and VHDL, right? So mostly Verilog is used in industry, right? It is a .v file, okay? Now, any hardware can be defined or designed using what? Hardware description language, right? It is a coding language, which it is a not software language. It is a hardware. It is describing what? Hardware design. So in Verilog also you cannot simply write. How you can write it? So in Verilog you can write in 3 to 4 different ways. Those are called as modeling styles. Verilog modeling styles, right? What are those modeling styles? Yes. What are those? Behavioral.
Data flow
Yes. Data
and
flow second.
structural.
Data flow, structural, and gate level, or you can say switching level also, right? So these are the four, you can say switching level better. It is a transistor level. Okay, so gate level is nothing but this one. Okay, behavioral, data flow or gate level, and switching level. Okay, out of these, which one is easier to define or describe a hardware? Which one? Okay, we'll go one by one. Switching level means, yes, Vaidhi, that is correct. We'll see one by one. In switching level, we define hardware in terms of transistors. So it's very critical, right? It's very complex now. Who will define each and every MOSFET, PFET, and NFET, right? It's very tedious task. Then comes gate level. You define each and every gate in your design. It is also tedious task. For small design, no tedious. But if it is a big processor design, how many logics you will define? Headache, right? Data flow. How data is flowing? You need to define the functionality, Boolean functionality expression. So what is the Boolean functionality expression for 2:1 mux? S0 bar I naught plus S0
Yes, I1.
I1. Right, this is the Boolean expression functionality for 2x1 mux, right? If you define how data is flowing, you will get the output. So this is how you can define in data flow. So finally comes behavioral. So how you can define 2:1 mux in behavioral model? How we can define? So behavioral model. Yes, anyone?
Using case statement.
Whether we require gate knowledge, gate logic knowledge in behavioral model, yes or no? Do we need to know how many ands are required, how many nots are required, how many ors or logic level knowledge is required? Not required. Here we only require what knowledge of hardware? Only you should know about the behavior. That's all. If you go near to go visit any temple, you will see there will be lot of beggars sitting outside temple, right? So you will be donating something. So if you donate, right, 1 rupee coin nowadays, what they will do? What is the behavior of beggar? Most of the cases he will give back 2 rupees to you. Take mine also. Donate you only. Right? That is the behavior of beggar. Then you tell, come, I will give you work. Beggar won't come. You give me money. So that is the behavior depends on. Now you give 500 rupees note. What beggar will tell? God bless you, give you lot of what wishes and all. May your wish come true. Blessings, everything. Beggar will also be happy. Today's quota is done. Receive lot of money in my account. Huh? Then you give some food, feed some food. Maybe that much blessing will not come, but some blessing will definitely come. So basically, see what is happening here. Based on your inputs, you have given 1 rupees, you have given 500 rupees, you have given food, you told him to come, I will provide work in my company, right? So out of all these are what? Your inputs you are providing to the system. System is nothing but that beggar. What is the outcome? Is the behavior of that system based on what? Inputs, right? So this is, let us assume that we don't know what is there inside. It is a unknown thing. How you can decide the functionality of this? Based on its behavior, and that is dependent on inputs. Now, how many possibilities of inputs are there to decide the functionality of this unknown system? How many possibilities of inputs? It is based on number of count of inputs, right? Here, 3 inputs are there. How many possibilities of inputs can be there, right? It is 2 to the power n. N is nothing but the input of system, which will give 8 possible inputs. For 8 possible inputs, what is the outcome, right? For that you need to write truth table, right? So I0, I1, S0. So for 0, 0, 0, 0, 0, 1, 0, 1, 0, it's like that you have to write 8 possible inputs. What will be the output that you have to write? So from the outcome, we will understand that, okay, the functionality of the system, how it is behaving. It is behaving like 2:1 mux conditional, right? So what we are telling, so how you can write behavior? So like a beggar's behavior, if I give 1 rupees to a beggar, then beggar throws it, right? Else if I give food, some behavior. Else if work is given, rejected, beggar only rejected the recruiter, right? Else if I give 500 rupees, happy, right? So behavior is keep changing because of conditional inputs, conditions. Same way you can write here, if S0 equals 0, right? Then what is the output? I0, else y equals I1. That's all. So this is nothing but the Verilog behavior code. See, anywhere I have written logic gates. Do you find any logic gates in this code? No. So the best modeling style, Verilog modeling style, HDL modeling style is define any hardware by behavioral model. If you define that, definitely it will become easy for uh, to write the RTL logic for any design. That is why this behavioral model is predominantly used in industry. Okay. So once RTL logic is done, right? First is what? Specification. Second is what? Architecture. Third is what? RTL design. This is designed using Verilog code, right? Fourth is, okay, you have defined some behavior for 2 cross 1 mux, right? Now, fourth important point is what? We need to verify also, right? We need to verify whether it is really operating as a 2 is to 1 mux, because here there are no logics. We cannot be sure that is it really working or not working. So how you are going to verify the design, RTL design? So for that we have design verification, right? Design verification is done based on all possible inputs. So this is one way. Or else you can write test bench, or else you can write test cases. But what if it is a billion transistor level design, right? A very complex behavioral model is there. Then how to check? So for that we have design verification environment, right? So in this environment you will have design under test, one component where you will have the design. It will be connected to multiple blocks like monitor, scoreboard, like that. It will be connected to multiple blocks. So it is kind of system to verify any complex design which has 2000 inputs, which has 4000 inputs. Very difficult, right, for those design. So for that purpose the environment is required. That is why we require system verilog for them, design verification, and UVM, verification methodology, right? So this is nothing but verification methodology. So this is used only if your design is complex. We cannot write truth table for 4000 inputs. For smaller design it is easy to write. How you are going to write? You will give stimulus, right? So if I0 is 1 tick B0 means what? I'm giving some input here, right? One bit and one binary input. If I1 is something like 1 tick B1, right? S0 is something. So if you give some inputs, what will be the output? You have to check. So what should be the expected output if I0 is, if I0 is 0, 1, 0? What should be the expected output? What should be the expected output? 0, right? If you are using select line 0, it will give output for I0, right? So I0 is 0, it will give, it should give 0. But what if somehow it won't give 0, right? Instead of that it is giving 1. Then what does this mean? Design failure, functionality failure, functionally failed. Your design is so your design is not acting as 2 cross 1 mux. Functional failure is there, right? So this is checked in design verification itself. So this is not just for functional failure. Sometimes what will happen, out of 1000 inputs, if 99 to 98 possible inputs percentage is passed, right? passed all, you're getting desired output, then your design is passed, we'll say. So that is called as functional coverage. So DV guys or DV domain people will also check functional coverage, whether design is meeting functional coverage or not. So this is part of design verification. Once all this done, once your design is verified, logically correct, right? Then the fifth step is very important step, that is called as synthesis. Fifth step is called as synthesis. Once all this done, it goes to synthesis. What happens here? So this basically converts the RTL behavioral code dot we design into gate level netlist. Okay, what is gate level netlist? Converts all behavioral model style into gate level style. Gate level style means, see, your mux is there, right? How many gates? One and, second and, one or not, right? For all this, you will write the connections, how it is connected, right? How it is connected. So you're going to write the connection. So this is and 1 and 2. So how the output is connected to the inputs, you will write pins net like this. You are going to write in terms of gate logic, that is called as gate level netlist, right? Now any part of this 4 step, have we discussed anything about technology node? Whether any technology node comes into play? No. Why? Because these 4 steps are not part of physical implementation. It is not part of physical implementation, right? Physical implementation starts after synthesis, post synthesis. Till synthesis, it is just a conversion of behavioral complex code into gate level logic code or circuit. It is nothing but gate level logic circuit. So synthesis is nothing but the breaking of complex design into smaller chunks. It's like you eat food, your body also does synthesis, right? It's like leaf. Leaf is doing photosynthesis. What it is doing? So once there is a presence of sunlight and enough amount of water is there, so what it starts doing? It starts breaking glucose, right? That is from where you are seeing the green color in leaf. Same way you eat food, so insulin level will spike, and then what will happen? It will start breaking down your food into glucose, and it will dissolve in bloodstream. That is how you are getting energy. So that is also part of synthesis. So synthesis is nothing but breaking anything which is complex into easier understandable code, which is called as gate level netlist, right? But the catch here is the gate level netlist is dependent on technology node. Why? Technology node dependent. Why? Because the once it is getting converted into logic gate, it is also mapped with technology dependent library. So we have discussed predominant cell, remember? Predefined cell, not predominant, pre-designed cells, right? In semi-custom. So those are mapped with technology dependent cell. That is why we are telling the output will be technology dependent cell. So once you get this netlist, this is also .v. So from here onwards, your physical design will start. So from here onwards, physical implementation will start. Okay. So the first step is called as floor plan in physical design. Second step is called as placement. Third step is called as CTS. Last step is called as routing, right? And final step is sign off. So these four steps are part of physical design. And once sign off is done, you will get last output, which is called as GDS2. This is your final output. Okay. Now out of these, right, out of these, the first portion comes under front end design. You might have heard this word. So this is part of front end designing. And rest portion is comes it is part of back end of design. Understood? We'll see if in physical design now we'll see each part, each stage one by one. Understood everyone? Which part is front end design, which part is back end design, which is logical implementation, which is physical implementation. So the front end of design is basically logical implementation part. Nowhere we are talking about size. Nowhere we are talking about width, length, depth, or any fabrication related issues. We are not discussing that. In first half I have discussed fabrication related issue. Remember what was that? On chip variation, and that is due to process, voltage and temperature variation. Those are the variable factors. So that is completely physical aspect, that is must to know as a physical design engineer. So that is not part of front end. Okay. So let us start with the physical implementation. So these things we have already discussed, right? Chip fabrication. Okay. GDS2 I'll explain later on in the end. So first part is, yes, now you have to answer, right? What is the first step? Specification. So specification is always decided with respect to what is the requirement, what should be the performance, area, right? And power requirement. All these parts we need to decide. Cost with respect to specification. If you are designing a mobile processor, you need memory, ALU, GPU, CPU, multiple blocks are required, right? Those all comes under specification. Architecture, right? After deciding complete blocks, you need to decide the block level connections also. What are the things required, right? It is nothing but kind of block level diagram, right? And each block, what is the power requirement, cost requirement, so everything will be defined. Then comes RTL design, right? So any design can be easily defined, hardware level definition can be given with respect to what we are going to use, behavioral model. It is easy to define it, right? Then RTL verification, you can write, you can see here example which is given here. So these four lines are nothing but called as stimulus. These are called as test inputs, right? In this way they are giving test inputs. So this complete code is called as test bench. So they have written test bench and giving these stimulus to check the output waveform. So tools which are used here is Xilinx ISC or Vivado. These tools are used. Maybe you have also used in your maybe graduation, right? Which is used for simulation purposes. Then comes synthesis, converting the RTL code into gate level netlist code, right? Only
difference is that the output is technology dependent. The independent design, technology independent design is converted into technology dependent design. Understood? So it is converting, you can see here example, it is converting a design into gate level netlist. You can see it is defined in terms of gates and or inverter and how many possible inputs. So after this, right, during synthesis only, we will also insert DFT logic. What is DFT? Design for testability. To improve the testability feature in design, we will also include scan chain blocks in design, right? Scan chain blocks like MBIST, memory built-in self-test, right? Or BIST, built-in self-test logics. So these are inserted in the design. ATPG, automatic test pattern generator. Suppose if you have a very complex design with lot of inputs, it's very difficult to check. That is the reason ATPG is introduced. So the first step in physical design is called as floor planning, right? So floor planning has multiple stages. So first stage is to create core and die area, right? Remember first phase where we discussed how wafer and how it is cut into small chip. So each chip has a complete floor plan design. The external part, the external boundary is called as die boundary, as you can see here also. And internal boundary is called as core boundary. So after this is done, you have to place ports, right? Then place macros. Macros are nothing but IPs, bigger blocks like memories. You have to place it. Then maybe if you have a voltage area or power domain, that has to be created, right? Then some physical cells will also be added and blockages will be added as per requirement, right? So this is floor planning. Then once your floor plan is done, right, you need to place standard cells, right? Remember predefined or pre-designed cell I was talking about. So if you don't want to design your design from the abstract level of transistor, right, which is very tedious, I want to design it from predefined logic itself, right? It is like a Maggi masala. See, you go and purchase a Maggi. How you will cook? You will take a Maggi and you will open that Maggi masala packet, you will add it and simply done. How fast it is done? 2 minutes it won't be completed. Of course, they will claim, but it won't. But it is faster or not. Suppose if someone tells you that go and take all raw spices and do grinding and take that spices and add in Maggi, definitely that will taste differently and good also possibly because the freshness in spices are there. But it is not faster way. Suppose you want to cook it for like 1,000 people, Maggi only, right? You won't go with grinding all the spices, right? It will take a lot of time. Of course, the quality is better, but it will take a lot of time also. So better way to reduce timing and effort, what can be done? Use already standardized masala. Those masala is called as standard cell because those basic logic or cells are already pre-designed, standardized with respect to timing, power and area. Now you need to pick those cells and you can just design it, connect it. So you see here in screen, these are the examples, right? These are all standard cells. So it is enclosed in PR boundary, right? It is called as one box. That box is called as PR boundary. You won't see that representative symbols like and or, right? So basically all these are simple basic logics only, like what and or full adder, all these will be placed. But question is,
whether it is placed in right location or not. If you are placing it, it should not overlap with other cells. As you can see in first picture, that it is getting overlapped, right? That should not happen. Why it should not overlap? If it gets overlapped, what will happen? If two standard cell overlaps, what happens? What short? What short circuit? I have given you basic briefing on complete picture, right? First phase. Now you have to think in that level. You cannot tell short and all this one word answer. What will happen during fabrication? See, in the end, these all cells are physical cells only, right? It will violate the rule. What rule, Vaidi? It will violate. See, all these are having internally, those cells are having transistors only. MOSFET, right? DRC, which DRC, Vaidi?
Design rule checker.
See, inside that transistor is there, MOSFET is there. Now one MOSFET is there and second MOSFET is there. Okay, inside MOSFET I have discussed, right? There are many layers: substrate, diffusion layer, poly. What happens if two MOSFETs come on top of each other, right? Or two cells come on top of each other? What will happen? Those layers will overlap or not? Problem is not cell overlap. Problem is the layers, physical layers which is present in the cell, that will get overlap. So during fabrication, what will happen? It will not fabricate properly. No, substrate and substrate will get short. Poly and poly may get short. Diffusion and diffusion may get short, right? It will fabricate in that way only. See, it is how you design it. Mask will be placed like that and it will be, do the fabrication in that way only. That will lead to design failure. So that is the main reason. Okay, so that is why you need to legalize the placement of cells. So right location can be placed only in site rows. These are called as sites. Okay, site rows. So site rows are nothing but guide for placing the cells. It is like you have purchased a plot, right? So you went into gated colony, gated society, where plots are perfectly what we say partitioned. Between there is a road and all plots are partitioned like this, right? You can build your house in that particular site only. You cannot build your house in neighbor's site also, right? In your site only you can build it. So it's like a placement of house in your respective site only. You cannot go to other site. I will extend one, instead of 3 BHK I'll go with 4 BHK. I'll take some part of neighbor's house, neighbor's plot. That you cannot do. Okay, so those are called as sites. Similar way, here also we have sites. Okay, so these cell size, area or height, it should be integral multiple of these sites. Clear, everyone? Any question? So this happens in placement. Not only the placement of these cells are important, you should also take care of PPA constraint. You have taken care of area and other things, but performance and power is also important here. Suppose what happens, right? In one scenario, you will see. Suppose one cell is placed here, right location only, inside, and another cell is somewhere placed here. It is also present in right location, and these two cells are talking to each other, right? Placement is legally correct. It can get fabricated, no issues. Functionality wise also correct. What is the problem here? Time, right? Good. So important part is time here. What if you place this cell near to this cell? Definitely delay will reduce, right? So that is what the placement of cell in right location is also important. Appropriate location to improve what? performance. Same way, what happens if already lot of cells placed near to it and you don't have space to place this cell here? In that condition, what will happen? Hmm? If you want to place this cell near to this cell, what will happen in that case? There is no space. Then how you will place? Let's say, let's say all these cells are also talking with this particular cell, and it is talking to this cell also. What will happen in this scenario? And this also you have brought it somewhere near to it, and you have placed somewhere here. It is also talking. What will happen? See, if you have road like this, traffic road, yes, okay. Now what happens in that Belandur side, right, or the Martali, if you have visited there, lot of traffic or not, or near this Puram side also, right? You'll see lot of vehicles are there, lot of vehicles. What is happening? It is leading to congestion, right? Why it is leading to congestion? Is it because of more vehicles? Then, so population is increasing. We will reduce some population by killing some people. That will solve congestion. Easy, right? The problem is not population. Problem is resources. Problem is infrastructure. Population will increase. That is not under control. You cannot go into someone's house and tell them, stop, 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 don't reduce this population. Or no one will listen, right? Even though some people will listen, how you will restrict that? So it's very difficult to go into restriction at that level. So what can be done? The resources and infrastructure can be improved such that congestion can be improved. So if there is a lot of traffic here, right? They can create underpass, right? So some people in Bangalore, it's very, I have seen almost in all roads, there is no crossing also. People keep crossing anywhere they want. From anywhere they want, they will cross. We don't know from where some person will come in front of road and accident will happen. So what is lacking here? The overbridge in lot of places. They should, where there is a busy, like if you visit that Phoenix Mall, right? In front of Phoenix Mall, it is always crowded. Why vehicles keeps jamming there in front of Phoenix Mall? Because there is a lack of overbridge. If they have created the overbridge to cross it so that people can cross, because it is a mall area, definitely crowd will be more there. If there is a overbridge, so people can easily cross, right? Then traffic won't jam that much. Comparatively, it will be less only. So lack of infrastructure, lack of proper planning, lack of resources will lead to congestion, right? Same way here also, if lot of cells are placed here, right, definitely it will lead to congestion. Why? Because routes are limited. See, if you want to connect this cell to this cell, there should be tracks available, right? Metal tracks available. If it is not available, how you will route it? Understood? So if cells are placed far apart, so there are a lot of scope that I can route like this. I can route like this also. I can route like this also. Why? Because that space is available to route these two cells. But if it is close enough, you cannot jump on top of cell and then you cannot route it, right? So possibility is there, but less. So the routing resources reduces if cells are placed together. So you need to improve the resources, not the cells. Cells we want anyway because We need to improve the performance. We need to improve the functionality of design. If you keep removing cells, I'll remove this cell, then you will not meet the functionality. It's similar to this. You cannot touch population here. You can only uh, manipulate, or you can only improve what? Resources, infrastructure, right? So congestion is also very important in placement. That also we will discuss during the course very intensely, and we'll see all the scenarios, all the difficult situation in the design, and how we can overcome those designs, right? Problems in design we can see. So I have just given small example here, so for the basic understanding, right? If I tell you more advanced thing, you won't get lot of things. Okay. So next, after placement, what is the next step? Next step is clock, right? So in floor plan, you have completed floor plan placement, you have placed cells. Now you have lot of sequential cells in your design, flip-flops. Those needs to be clocked or not through clocks. So clock routing has to be done in CTS. Now why we call it a synthesis? So if there are two ways now. Okay. Suppose you have a clock port here, and you have all these flops present over here. Now you want to clock all these cells. How you are going to clock it? So one way is that you clock directly from port, or I will draw like this, directly from port. Okay. What will happen? What will happen? Or I will also draw the second way. So let's say this is a port, and you have these standard cells. So what I can do, which one is better, first case or second case? Why
Second case.
second?
Second.
Why second case is better? Organized, because second case looks organized. So that is a basic level answer. You can tell that okay, it looks organized. But why it looks organized? Also, if you observe, less Prajwal, yes, less wiring and reduce crosstalk. Very good term here, crosstalk, right? We'll discuss that also. Clock will reach every cell at the particular time. Yes, Vaidhi, that is also good point. See, if you observe, it's quite clumsy here, right? If you observe this part, what is happening? Lot of resource involvement is here, right? Routing routing resource will increase tremendously, right? Timing will get impacted. Your delay will what? Increase. Timing will degrade, right? And as Prajwal said, right, there can be lot of crosstalks also. That is very important here, right? Why crosstalk? Well, first of all, what is crosstalk? What is crosstalk? See, it's like in your school days, you used to go to some class, your English madam, in English class, you and your friend both are talking with each other continuously, sitting at maybe back bench or middle bench, I don't know. But wherever you are sitting, you are continuously talking with your friend, right? What madam will do? Hmm? What madam does? Madam or sir? Scold, even if you not listen to madam. Then
Make them sit somewhere.
Kick out.
make them sit somewhere else, means separate them. You sit here in front, you go somewhere else, right? Make them apart from each other. Like usually when there is a new session in school, what teacher used to do, you both are best friends, you should not sit together, you always sit that corner, you sit here. Like that madam will do or not? So here also, if most of the routes are flowing in parallel to each other, there is a high chance of cross coupling capacitance, right? It will it will generate a cross coupling capacitance between two nets which are flowing near to each other. This is called as cross coupling capacitance, right? So this cross coupling capacitance affects your timing. If your transition is from 0 to 1, right? What will happen if your transition is in same direction here also, 0 to 1? Or if the transition is 1 to 0 in opposite direction, what happens during that time? Either the timing, so this is, let's say, aggressor and this is victim, either your timing may improve or it may degrade based upon the transition is in same direction or in opposite direction. So either this net, the victim net, can become faster or slower. Making this particular net faster or slower, it affects overall timing of your design, right or wrong? Right? So due to this crosstalk or due to this cross coupling capacitance, if it is more, it will impact your overall timing, right? It is a signal integrity issue, right? To avoid that, we should have a good CTS structure or CTS algorithm, one thing. And if you see, observe, from this point to this point, it is going to this cell, right? How long is this net? It's a very long net. Definitely timing will degrade here also. Now, if you observe that it is quite organized compared to this, right? It is a straight way, but sometimes more cells are there means it will go like this also. And then it will come back to this. Then also delay will be increased. But if we have an organized spine, this is called as fishbone algorithm. Fishbone. So this kind of CTS structure is called as fishbone algorithm. Why fishbone? If you see a fish, right? Fish skeleton. So how it looks like? So there are spine on fish, right? If you have observed something like this. So this is what skeleton of fish. Then further, if this skeleton can be expanded, something like this or something like this. So it is expanding like a fishbone structure. That is why it is called as fishbone clock tree structure. Like that we have H tree, Y tree, multiple. We will see that in advance, right? So this is very helpful. It helps in latency, improving latency. It helps in improving skew compared to the first case. Latency is nothing but the maximum delay from your clock port to your cell. It is called as latency, right? Or it is called as what is your capture time minus launch time. So that these somewhat complex terminology, we will learn this in STA sessions. Some STA concepts are there. Okay, so this is part of CTS. Next, next is routing, right? Once clock routing is completed with respect to power, performance, right? So why performance and power can degrade, right? If you are not following proper clock tree structure, because clock, now power is also very important here in CTS, because clock is very much affected, right? It is very much affected by power also, right? So why? Because there are two types of power. What are those? dynamic power and static power. Dynamic power is dependent on, again, it can be segregated into short circuit power and switching power. So these clock nets, right, it is affected by switching power. What is switching power? Buttons. Where buttons are coming from? Not that buttons. We are, that's why I told na coronavirus. We are working in nano scale. Where you will get that switching button? Yes, switching between the charging and discharging of capacitor, right? That is how your clock pulse are generated on. So you can see, you are seeing clock pulse, right? Continuously switching from 1 to 0, 0 to 1 or not. Whether, practically speaking, whether we see clock like this, no. Practical clocks are always having the transition. You will never have an ideal condition in clocks. So this is a practical clock. Okay. So switching power depends on alpha FCL VDD square. Right? It depends on switching factor, it depends on frequency, it depends on load capacitance and the supply. Right? So if you see frequency, if you have a faster frequency, let's say like this, compared to this lower frequency clock. If you have a faster frequency, what will happen? If the clock is faster, your switching power will increase, right? If your clock nets are longer, see longer clock nets, what will happen? Load capacitance will increase, right? So if your transition is more, then also it will affect short circuit power. You getting? Some part you will definitely get, right? I am not expecting that you will get everything. Okay. So understand that clock will get affected. It will affect your switching power. So if you are not doing right clock tree structure, it will definitely impact your power dissipation also of your design. And nowadays power is a very crucial parameter. Why? Because you want smart watches, you want smart earphones, wearables without any wire, right? Your phone should last longer. It should not discharge faster, right? For that reason, the power saving is very important here nowadays in current design. Low power based designs, right? That is why the power saving techniques we will teach you here in course. In what ways in low power design can be designed. Okay, so final step is the routing, where every clock routing is completed. Then what is the final thing remaining? Signal routing, right? So signal has to be routed. Once clock is routed, power is routed. So final step is connecting all data signal routes from memories, from ports, from all the standard cell logic. So based on its functionality, so from where it is drawing this connection, how it is knowing that I need to connect standard cell 1 and standard cell 2? That information is coming from which file? Gate level netlist file. Remember, we have discussed it is a circuit file. It is a design file where it shows the connection between the logic. So from there it will draw the information. Based on information, it will connect. Based on those logical connection, it will connect all these cells physically. Means physical layer will be drawn, metal layer, interconnects. Remember, I have drawn one MOSFET device. I told that interconnects will be using one material, that copper material or some material. So here is, it is nothing but doing that interconnects, connection of all the devices, all the cells in your design physically. There is no more logical connection or logical design here. Everything is done physically. Whatever connection is made here, that will be fabricated in final design. Okay. So once These all steps are completed. So sign off is the final step where you are going to validate your design with respect to timing, power, and DRCs or physical verification. Right? In timing, you are going to check your extract the real RC value from your design to calculate the net delay. That file is called a spef file. So you are also checking IR drop. What is the IR drop in your design to check how much power is getting impacted, right? If your IR drop is high, what will happen? Voltage drop will happen or not? See, it's similar to at your home. Instead of thin wire, if you're using thick wires, what will happen? See, in railway station, you have seen high tension wire, right? Thick wires. You use that in your home for connection. What will happen? High resistance, right? If high resistance is there, then load will increase. Your meter will run like Usain Bolt, right? Your bill will come like Ambani's salary. So you should not use thick wires because it will increase the load, right? So that is why we are using thin wires at home. Is how much thin? If you use very thin wire, then what will happen? Very low resistance. It will also draw high current and it will burn your wire. That is what we will call short circuit ho gaya, right? Somewhere. So that also we need to take care. You should not use very thin wire or very thick wire. That will increase resistance. If you use high resistance material, that will cause voltage drop. If voltage drop is there, the supply which is you are giving, right, that initial operating supply won't reach the device operating voltage. Suppose your fridge is there, the operating voltage is at 240 volts and your supply is also 240 volts. It should reach, right? Why it's not reaching? Because there is a voltage drop due to high resistance of wire. Understood? So that is why higher drop is very important with respect to power. Last check is related to physical verification. So basically there are three checks done here. One is DRC, second is LVS, one is DRC, second is LVS, and third is FV, functional verification, or it is also called as logical equivalence check. Okay, DRC is check, which is the rule check, right? It is a design rule check. What is these rule? These rules are fabrication based rules, which is given by Fab Labs. Now, what are those Fab Labs? So I will tell you, but these are fabrication based rules. Suppose there is a diffusion layer, another diffusion layer, two diffusion layer should not be placed very close to each other. A minimum spacing should be provided between two specific diffusion layer, right? That minimum spacing is nothing but called as rule given by fabrication. What should be the minimum width of any particular layer, right? Why these rules are provided? Because fabrication people are telling that our setup is set to this minimum condition and this maximum condition. If you want your design to get fabricated, it should meet that constraint, right? It's like you're going to a carpenter and you want to design a bed, right? You are giving an order, so the carpenter will give you some constraints or not, or you will give constraints or not, or if you just tell, just give me a bed. So he will create a bed of 100 feet height. Then you will tell why you have created 100 feet. I haven't told. So you also didn't give constraints, right? So you should give constraint. Make only 6 feet, 7 feet height bed, right? With this much of width. So you are giving constraints, some rules you are giving. So you have told make bed made up of wood, right? He has made bed made up of gold. Now you're telling I will not pay this much of amount because, or he will tell I don't have this much of gold. You have told made up of gold, right? He'll tell I'll make made up of wood only. I don't have gold. Like that. Like that, fabrication people will also give us rules, constraint. You have to follow it, right? So those rules like minimum spacing, minimum width, like that, there will be many rules we will discuss during session. LVS is nothing but comparison between layout versus schematic. Now, what is the schematic? Schematic is generated from the golden netlist. What is this golden netlist? The synthesis netlist, gate level netlist. This is our golden netlist, and layout is your, once your routing is completed, you will generate a netlist. That netlist is the layout netlist generated from the real design. Once your physical design, physical routing is completed, from there netlist is generated. This netlist and this netlist will be compared. Why? Because this is golden. Why we are saying golden? This is the functionality what we want from our design. But during physical layout or physical routing, design can change, right? Due to routing, it can somewhere, it can lead to shorts or open. Then what will happen? Functionality will change or not? So if both netlists are mismatching, we will say LVS failure. Okay. Final check is the functionality check, logical equivalence check. Functionality is intact or it is compromised. That you need to check here. Right? Usually non-EQ checks are there. Equivalence check, we'll say. Non-EQ check means non-equivalent to the golden netlist. That is what we say. So these all checks are done in the physical verification, the final step. So after these checks are okay, we will get what? Final output, that is called as GDS2 file. This is that file which will go to the fabrication team for fabrication, right? Okay. So these are the tools which are used. Basically, in VLSI, there are three types of company. Okay. One is design-based companies. So I haven't told about the companies, right? So basically, there are three types: design-based companies, EDA tools-based company, and fabrication-based companies. Okay. Design-based companies are like Qualcomm, NVIDIA, right? Any other you can tell? Marvel, Samsung. Samsung is both design and fab based company. So Samsung is both design as well as fab based. It has its own fab also, right? But Intel is also both design as well as fab. It has its own fab. TSMC does not have design based company. It is purely fab based company. Overall worldwide, it produces 85% of fabrication chips. Global foundry, right? So it is an American foundry. So this is also fab based company, not design company, right? TSMC is the major giant in fabrication, 85%. That is why China is behind what? Taiwan, trying to acquire Taiwan, enforcing its power on Taiwan, because they know TSMC holds 85% of global market. That much scale is there. Okay. EDA based companies are Synopsys, Cadence, Anisys, Mentor Graphics. Now this is acquired by Siemens. Okay. These are EDA based companies. OnSemi also creates some tools. This clear? Any questions? So this is the complete flow of physical design. So if you have any question related to course structure, subject, or
jobs, anything you can ask me. So this is the end of session. I'm open for questioning. If you have any specific question, you can ask me. I'll answer it. Yes, anyone online, if you have any question online or offline. Sir, do you have any hiring partners which are product-based companies? Yes, we have hiring partners. So it's basically product-based companies are not evergreen hiring companies, right? They usually go for freshers that from tier one only. After that experience level, they will hire very less. Okay, one or two or five, that is rare. Means it is not like regular they're hiring every month or something. Even though they hire, they'll choose for some tier one or something like that. Okay, so yes, we also have partners. We cannot tell requirement, we can tell. So we will also get the requirement from product company that we want some good students. In that way, that opportunity comes from product. So usually they partner with tier one college only, IIT or NIT kind of colleges. Sir, do you have any sir, if I start my career in physical design service based company and gain 2 3 experience, good hands-on experience, will it be possible to switch product based company? Yes, Pranita, that is what I was telling. Yes, it is possible. So if you are working in service, it's not like you will never go into product. You work in service. Nowadays, service companies are paying more in some service company if you go, no? It is paying more than product company once you are experienced. You understanding my point? If there is advantage and disadvantage both. For initial time, if you go in product company, they'll pay you higher. But once you reach at certain amount of money, right? Then after that, they won't increase much. One second disadvantage is that whatever they will take you for some domain, right? You will be stay in that domain for long years doing same thing. You cannot go back to something else. But in service based company, you have this always scope. Suppose you are working in a Qualcomm, right? And you're working from a service company, you're working in the client Qualcomm, right? And you work for some years on some domain, physical design. Later on, you come back to your own service company and tell that I want different line in STA also. So they will send you for STA profile also. That scope is not there in product. No matter you ask your, well, no one will listen in product. If you are chosen for one domain, you will be remain in one domain only. You cannot able to see what is happening in other domain. So that scalability is there. Nowadays, a lot of service companies paying much higher compared to product. That is different. And one more disadvantage is there, that they can anytime lay off also. Product companies are very much having the higher threat of getting laid off. Recently, Google has laid off some 4,000 employees. Right? Google pays a lot compared to other product companies, even though they are not developing processors. But recently, they have laid off 4,500 or something. If you have read it, I mean, 6 months back, Synopsys has laid off 2,000 employees. Right? So it does not mean that they're paying good salary means it is a good company. Good company is that company only which provides you stability. Every time you don't need to search for new company means that is no stability. So if high amount is there, if company needs to do cost cutting, the first thing they will remove that high salary people. Like Intel. What happened to Intel? We all know. Intel was top in VLSI in stocks and everything. How it came down. Now Nvidia is in top. It's not like Nvidia will be always there and top. We don't know. Someday or other companies comes up with new innovative technology that will go up. Nvidia stocks will come down, and they will also start laying off. That is a big stability is a big disadvantage in product. Service, what will happen? Suppose you are taken out of one of the client.
right? That company has partnership with all the client product companies. They will send it to your other client, other product company, where you have scope, where they need you. So in that way, your learning will be like anything. But initial period, definitely there will be some struggle in VLSI. That is expected. Do companies give preference to candidates who complete offline training, or are the opportunities same if skills are good? See, offline or online, right? It doesn't matter offline or online. Important thing is how much you have learned, right? How much is your skills? That is important. If you are good at it, definitely you will get a good opportunity also. So, but if you ask my personal opinion, I'll go with offline training. Why? Because if you compare, you can choose both, right? But I have observed from my past experience from other batches, what I've seen, the batches who are attending offline, they are more focused, more attentive, more serious, because they don't have other distraction when they are attending offline. They're facing the trainer face to face and actively uh, involved. Even though you get distracted, again you can come back to the subject. But if you are studying at home or in PG or something, if you can cope up, it is well and good. But sometimes what will happen at home, you will see bed, you'll see TV, you'll see some distractions. Some way or other way, those things will be calling you. Like you have seen Chandramukhi, right? Chandramukhi will keep calling king. So like that, it will call. So that scope is not there when you're attending offline. You will be pushed towards a mold, right? So that in that way, I feel that it will be helpful for you. Okay. Any other question? I hope you learned today few new things, right? And understood few things, how VLSI work, how things are there, and what are all different scenarios. If you have any other question, you can ask. I'll wait for 2 minutes more, and then we will end this session. Okay, then thank you everyone. I hope you enroll for this course. We will meet in advanced sessions. Thank you. Harsha, I am working as a hardware engineer. Which course would be better? Hardware engineer means you are working in PCB and networking kind of domain. Huh? Can you clear that? Hardware engineer is a very broad terminology. Lot of you are see whatever we are learning here in VLSI, that is also part of hardware design, not engineering. Pranita, sir, approximately how many students from the single batch have been successfully placed? Also, what is the highest number of students placed from one batch? See, this is a quite vague question, right? This all depends on how students perform, right? Our responsibility, our work is to deliver you the best, right? Deliver the support you require, whatever required, that we will provide you. Ultimately, the part which has to be played, right, important part, that is the individual person. If a person X is not coming to class regularly, missing his classes, and definitely he will have pending of things to cover, right? Then what will happen? He will lose interest, right? Gradually. He cannot cope up more advanced sessions. Then he will start missing classes, not coming into classes. In the end, what will happen? So he need to revise complete thing, right? That headache will come. So we cannot assure in those scenarios that we can help you, because the individual level also, your part is also there, which you need to play. That is very important part. So even though, right, the important thing is you attend all classes, go through all tests, mock interviews. If you have any doubts, ask the trainer itself in class, right? Do not keep it for delay. No, what I will ask, I don't know anything, right? If you feel, if you be in that zone, right, then it is disadvantage for you only. So because you don't wait for to complete your course and then I'll ask question means, then you will forget also what I need to ask. So that is important. If I have seen batches which was very good, fast learner, I've seen batches which were very slow and maybe their basics were not strong. That kind of batches also I've seen. So I've observed that it is not about slow learner or fast learner. Slow learner, what will happen? 1 or 2 months afterwards, you will get a job. Max that can happen, right? But important part is whether you are sincere or not, sincere in learning or not, or you are getting distracted by XYZ reasons. So then no one can help you. If you are getting distracted by, nowadays, it's very easy to get distracted. The best distraction is in your hand itself. If you ask me 10 years back, those days we don't have mobile phones also in our hand in college, because only that we used to go to booth, in college booth, that landline phone, we used to ask to watchman that we need to call at home. Like that communication used to happen. Slowly we had that Nokia phone, that time also I used. So that is very low level distraction. So nowadays the bigger distraction is in your hand only. Harsha, I am working as a hardware engineer in embedded. Which course would be preferable? So if you choose embedded domain, that will be definitely helping you, Harsha, because you are already well versed with embedded terminologies. But if you want to switch into VLSI, so physical design will also help you, because but thing is, embedded is also having coding part, right? Embedded C and C language, you should be good in those things, right? If you're good in language and code, if you feel, right, you can choose front end also, Verilog or these kind of codes. Okay, RTL designing or design verification. But if you find interesting how this physical fabrication works, how this physical design works, physical implementation, how this see whatever the front end is doing, that is all imagination, logical imagination. So in physical world we have n number of issues. The first phase of this demo session I have explained, right? So chip, it can have on chip variation due to n number of reasons, due to process, due to voltage. So those things are very critical in physical implementation. That is the real design. If you ask me, total time taken in complete design cycle is most time taken is in physical design only. The front end takes almost 30 to 35% of total time, right? Whereas 60 to 70% of time consumed in physical design itself of total design cycle time. I am working. See, if you are working in embedded and you have a 2 years experience and you want to switch, I am telling, so what will happen, that you will be joining physical design as a fresher only. That embedded knowledge won't work here. It will not help you. Any company will see you as a fresher in physical design. Even if you work in IT or computer science or software, you will be seen as a fresher in VLSI, not experience. No matter how many Java, .NET, C Sharp you have learned, okay, that won't be counted here. Of course, that will be given you as a plus that you are good in programming, but you will be taken as fresher only. Sir, can I join course? I am asking because my background is yes. Pranita, this I have told, right? I've seen some people from MSc, BSc Electronics in my company who are working in VLSI, right? But different domain, not physical design. You can check with management also on this, or you can check through some LinkedIn or something whether someone is working in VLSI or not. Post silicon validation, I have seen, Pranita. In post silicon validation, there are BSc Electronics students. So usually they will test the chips using probes. Okay, real time test will be there. So there will be one prototype silicon from the fab, and they will test by connecting the probes. That is called as post silicon validation. Once sign off is completed, so they will do this PSV. Okay, any other questions? Okay, then thank you everyone. We'll start.